Hey everybody, welcome to our last unit in this semester, and this will be a unit on rational expressions, basically fractions or division problems that involve variables that often can be factored and simplified. So that's what we're going to talk about today. How would we try to simplify these types of expressions? We're going to look at a normal simplifying problem and then multiplying and division as well. But before we get to any one of those, we first need to talk about something that's important to all of these types of problems, and that's called excluded values. So excluded values are numbers that variables can't be. Remember, variables can stand for numbers. You can plug numbers into variables into your problems to simplify, get certain results. That might help you to graph a function, for example. But sometimes variables are not allowed to be certain numbers, and an example here, you can tell that we have a division problem. We can never divide by 0. Think of if you had, for example, 6 different things. Now, you could divide 6 by 2 because you can split things up into 2 groups there. You could divide 6 by 1. You could keep 6 things into 1 group. You could even split it up into fractions of groups, right? But what you can't do is have 6 things and have no groups. You can never divide by 0, in other words. So, because you can't divide by 0, this expression right here, x minus 1, cannot equal 0. And what that tells us is because this whole thing can't equal 0, x itself cannot equal 1. Think about what would happen if x equals 1. If x equals 1, then that's 1 minus 1. And 1 minus 1 is 0, and we can't divide by 0. That is why we call 1 an excluded value for x. It's something that x is not allowed to be. And oftentimes, rational expressions that we're simplifying will have excluded values. You can sometimes have more than 1, sometimes have just 1, sometimes have 0. It all depends. Are you dividing by a variable? If so, there is something that variable is not allowed to be. It's not allowed to be anything that would turn the whole denominator into 0. So x itself can be 0. That's fine, right? 0 minus 1 is negative 1, and you can divide by a negative 1. But x itself cannot be a positive 1 in this case because 1 minus 1 would simplify to 0. So excluded values are something that we're going to have to keep in mind for the rest of these types of problems that we're going to cover throughout the unit. Watch out for numbers that your variable is not allowed to be. Now let's go ahead and talk about simplifying rational expressions, and I have an example here that matches the one that we just saw. We're going to simplify this following 3 steps. So first we're going to find excluded values, factor our problem, and cross-cancel at the very end to see what we can simplify with. So excluded value we just talked about here, right? We see that this cannot equal 0. And therefore x cannot equal 1. That's one thing that we're going to start with doing, identifying excluded values. Another thing that we need to do is to factor both the numerator and denominator if possible. So x minus 1, you can't break that down any further. But the numerator is something that you can break down. So how we would do that is factor like normal. Right? What times what is x squared? And we know this from past examples of the box method. X times x is x squared. What times what is positive 1? Well, you have a couple of options, right? You have 1 times 1, negative 1 times negative 1. But the only one of those 2 options that works or makes sense to use is this bottom one, not this top one. The reason is negative 1 minus 1 is negative 2, right? 1 plus 1 is not negative 2. In other words, while 1 times 1 is 1, we need to have negative 1 times negative 1 because only these 2 terms, negative 1x minus 1x, will give us that middle term, negative 2x. Okay? So factor the top, what we end up getting, and you can multiply this back out if you wanted to, x minus 1 times x minus 1 is indeed that original numerator. Our denominator cannot be factored. And only after you find the excluded value for your problem, that's part of your answer, x cannot be 1, that is part of your solution here. Only after that can you cancel anything out. So notice here we have 2 parentheses on the top, and we could put a parentheses down the bottom as well. Everything looks very similar, but you can only cancel 1 for 1. Okay? Don't cancel both on top in this case, just cancel one like term over another. What you'll end up is that x minus 1 is the simplified result, as long as x does not equal positive 1. So we're going to do a couple more examples very similar to this. But that's what you're going to do. You're going to factor, find excluded values, cancel, and that will allow you to simplify each of your problems. So let's take a look at a multiplication example. So you're going to simplify and find excluded values for the following problem. Now, we have a multiplying problem here, but all the steps that we just saw are the exact same. It just turns out that we have a couple of denominators and a couple of numerators to work with. So let's go ahead and factor first in this case. Okay. Factoring first will actually allow us to find excluded values more easily. So if we factor the top left numerator, that would be our perfect square factoring pattern. Notice that we can square root x squared and get x times x is x squared. We can square root 9 and get 3 times 3 is 9. As long as we have 1 plus and 1 minus symbol. Okay, remember it's always something plus something times something minus something when you're using perfect square factoring. You could have also used the box method for this. It would have gotten you the same result. Again, anytime you factor, it had better lead you back, if you multiply this out, it had better lead you back to what you started with. So far that's what we have. If we factored using the box method, in this case, x times x once again is x squared. What times what equals negative 12 but adds to give negative 1? Only negative 4 times positive 3 and negative 4 plus 3. Okay. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. If you multiply this back out, it gives you your original left-hand denominator. We cannot factor 3, so we leave that alone. Sometimes things can't be factored. It's okay. And lastly, 2x minus 6, we can factor this. We would use the GCF method of factoring. Remember, greatest common factors. 2x and negative 6 have something in common. Both can be divided by a 2. Right? 2x divided by 2 is x. Negative 6 divided by 2 is negative 3. Again, if you multiply that back out, it does give you your original right-hand denominator. So, now that we factor, we can find excluded values, right? What is x not allowed to be? So x cannot be 4. It cannot equal 4 because 4 minus 4 would be 0. X can be negative 4, right? Negative 4 minus 4 is negative 8. We can divide by negative 8 all day long. X itself can be 0 because 0 minus 4 is negative 4. We can divide by negative 4, that's fine. But we can't divide by 0, therefore x itself cannot be 4. Imagine what would happen if we had a 4 here. That would be a big problem. 4 minus 4 would be 0. That's why this is an excluded value for x. X cannot be 4, and it can also not be negative 3. That's another excluded value, right? Negative 3 plus 3 would be 0. We can't divide by 0. Lastly, 3 minus 3 would be 0. Can't divide by 0. Okay. That 2 actually is not relevant. We're only looking for what is our variable not allowed to be. We have 1, 2, 3 variables in our denominator. Usually that means 3 excluded values. The only difference would be if 2 parentheses overlapped. We'll see that in a second, so don't worry about that just now. 3 things that x cannot be: 4 and plus or minus 3. Now, after we factored, after we found excluded values, only now can we cancel anything out, right? So what can we cancel? What looks the same on the top and the bottom? X plus 3 can cancel out. x minus 3 can be divided, right? When you do that, you're left with 1, right? Anything divided by itself is a 1. And that leaves us with, finally, a 3 in our numerator. 3 times 1 is just 3. And in our denominator, we have a 2 and x minus 4. This is another part of our answer along with our excluded values. 3 divided by 2 times x minus 4. These are all the things left over in our problem from what could not be canceled, along with these things that x is not allowed to be. That's how you would multiply with rational expressions. One more type of problem that we can do simplification with when it comes to rational expressions is division. So for division problems, there's two main differences here. That's that we're going to need to multiply by the reciprocal, number 1. And when we look for excluded values, we will have to look at what has been flipped. So think about how in the past you might have had a problem that looks like this. Right? This is where you would have some fractions, you would divide those fractions, and then that would equal 1 over 4 times 5 over 2, right? You would multiply by the reciprocal. You would flip that bottom fraction upside down. It's the same thing here. This is one way that you can write a division problem, right? With that slash mark horizontally. This is another division symbol that you can use here. Okay, it means the same thing. Whenever you're dividing fractions, make sure that you multiply by the reciprocal. So what that's going to look like in this case, the left fraction does not change at all. The right one, because we're now multiplying, will flip. 3x minus 12 moves to the top, 7 to the bottom. Everything else, for most of the problem anyway, everything else will stay the same. Okay, we're still going to factor if we can. We're still going to look for excluded values. We're still going to simplify by canceling. So, what can we factor? Can we factor x plus 4? No, that cannot be simplified any further. Okay, it's not an x squared. Can we factor the bottom? Yes. That is an x squared. That is something that we can break down into a couple of different parentheses here. That'll be x plus 4 times x minus 4. This is perfect square factoring yet again, right? X times x is x squared. 4 times negative 4 is negative 16, and 4 minus 4 leaves you with no middle term. Okay, so you can use the box method, whatever you want to do, make sure that this multiplies back out, and it does, to give that denominator. We can factor the top right by the GCF method. Divide both of those terms by a 3, right? 3 times x is 3x, 3 times negative 4 is negative 12. 7, that is something that cannot be simplified any further. So before we cancel, and this is the most important part, students love to cancel things out. Okay? Get very trigger happy with those cancelings. You cannot or you should not cancel out anything until you find excluded values. And here's the other difference for division problems. Okay? Notice, looking back at our original example, while 5 was flipped to the top, it started in a denominator, right? Same thing here. While 3x minus 12 flipped to the numerator, it started in a denominator. Therefore, we can find excluded values not just from denominators, right? We can find excluded values here and here, but also from the numerator that flipped. In other words, x minus 4 cannot equal 0. This is how we would find an excluded value for our problem. X cannot equal 4 because 4 minus 4 would be 0. Normally you can have 0 in a numerator, that would be fine, right? 0 divided by something is just 0. But because this started in a denominator, for division problems alone, you must look at that top right numerator as well as your denominators for excluded values. So we have to look here, x minus 4, that has a variable. What is that variable not allowed to be? positive 4. Okay. Now we also look at denominators like 7. 7 doesn't have a variable next to it. There's no excluded values here, right? There's no x, right? There's no variable that we have to look out for. Over here, we have x minus 4, repeated, right? This was one excluded value. X minus 4, once again, will give you that 4 cannot be a solution. You only have to write that once. If I say x cannot equal 4, you don't have to tell me again that x cannot equal 4. I already know that. But we see here that x cannot be 4 because of the top right numerator as well as the bottom left denominator. X, finally, cannot be negative 4, right? Because negative 4 plus 4 would be 0, 4 minus 4 would be 0, 4 minus 4 would be 0. Okay? These are your two excluded values for the problem. These will be part of your answer. X cannot be 4 or negative 4. Only now can we cancel anything out because these are our excluded values. Now we can cancel some things, right? X minus 4 can cancel on the top and the bottom. X plus 4 can cancel on the top and the bottom. Those look similar. We're left with some 1 times 3, which is just 3. 1 times 7, which is 7. 3 over 7, or 3/7, is our simplified answer to this problem. But notice, in our final answer here, we didn't have any variables. That's why it's extra important that you look for excluded values before you cancel anything. If I just got this as my answer, without finding first my excluded values, it would look like I don't have any, right? If there's no variables here, it would look like there are no excluded values. X can be anything because X doesn't even exist. But if we remember that at the very beginning of our problem, we did have variables, now we see why it's important to find those excluded values before we cancel anything out. And that is where we will end the lesson for today on simplifying rational expressions. So we're going to come back Wednesday and Thursday in that lesson and take a look at solving rational equations. One more lesson after that, we'll deal with graphing rational expressions, and that will wrap up the semester. So happy practicing, and I hope this helped.